Welcome guys. In this lecture we shall discuss the group 5 elements. Group 5 elements. Now these elements are put in group 5 because they have 5 valence electrons, right? So the number of valence electrons they have made us put them in group 5. And then we call them the group 5 family. If we do not call them the group 5 elements, we can call them by the first member present in that family, which is nitrogen. So we can call them the nitrogen family, right? And then if we do not call them the nitrogen family, we can also call them the pnictogens. Pnictogens, meaning irritable compounds, right? And then they are called the nitrogen family because nitrogen happens to be the first member of the group. Nitrogen happens to be the first member of the group. Other members of this group include phosphorus, right? Phosphorus, arsenic. So nitrogen is N, phosphorus is P, arsenic is AS, right? Antimony. Antimony is SB. The Latin name is terbium. Arsenic, antimony, and finally bismuth. And finally bismuth. Bi. Alright? So these are members of group 5. Nitrogen, phosphorus, arsenic, antimony, and bismuth. So because nitrogen is the first, we call them the nitrogen family. And what are the characteristics of these guys? What are the characteristics of the group 5, of the pnictogens? So characteristics of the pnictogens. Let's see. Let's come back. Look at this series. Now, nitrogen and phosphorus here are stark non-metals. So nitrogen and phosphorus are non-metals. Arsenic and antimony are metalloids, meaning they are semi-metals, while bismuth is a metal. So you can see the trend. Metallicity increases down the group because bismuth here, or just like every other group, the latter members are metallic. Members in the middle are usually semi-metallic. All metals on top are non-metallic. So that's their physical property. Now, coming back to their chemical properties, what do we say? Number 1, okay, they produce a great deal of irritation. They produce a great deal of irritation if inhaled in concentrated amounts. If inhaled in concentrated doses. That's the first one. That's why they are called pnictogens. Okay? What can we say about the number of valence electrons? They have 5 valence electrons, right? So they have 5 valence electrons. As in the case of nitrogen. Nitrogen has an atomic number of 7, right? That's 2,5. If you use this electronic configuration, that's the main orbitals. Or if you want to go by the suborbitals, you have 1s2, 2s2, 2p, 2p3. So that by the time you add up these powers, you get a value of 5, right? So they have 5 outermost electrons. Phosphorus has an atomic number of 15. So what does that mean? Means that it also has 5 valence electrons, as you can see. Or you say 1s2, 2s2, 2p6, 3s2, and 3p3, as we can see. Okay, now what can we say about the block of these elements? They are p-block elements. They are p-block elements. And that is because their final electrons are located on the p orbital, right? Yeah. Okay. Then, what other points do we have here? What other points do we have here? Okay, so let's generalize. Which of them are metals? Are non-metals, sorry. We said nitrogen and phosphorus. So, the oxides of nitrogen and phosphorus. The oxides of nitrogen and phosphorus are acidic. Come on. But that of bismuth, right? Not even, bismuth is not even, it's not so much of a stable element. So the oxides of nitrogen and phosphorus are acidic, as you can see. Now, what does that mean? It means they are acid anhydrides. Now, what is the oxide of nitrogen? This is a stable oxide of nitrogen. Upon addition of water to this, what does it give us? It gives us HNO3, right? This is an acid. Just the same way NO plus H2O gives us HNO2, which is also an acid. So it means NO2 and NO are acid anhydrides. It means they're acidic. What about for phosphorus? Right, we have P4O10 in the presence of water and in the presence of nascent hydrogen. Nascent hydrogen is free hydrogen ion in solution produced for the purpose of a chemical reaction. So in the presence of a nascent hydrogen, P4O10, which is an acid anhydride, reacts with water to give us H3PO4, right? So it gives us H3PO4. And how do we balance this? How is this balanced? We need 2 moles of that. Okay, so this, if we introduce 2 here, this becomes 6 hydrogen ions plus oxygen becomes 8, right? This becomes 11. That's 13. So balancing hydrogen here plus that's 11 plus 3/2 O2. All right, then you can cross multiply by 2 to get you can multiply all through by 2 to get a linear equation. So now what this means is the oxides of nitrogen and phosphorus are shown to be acidic. HNO3 is a strong acid, right? While HNO2 and H3PO4 are weak acids, as the case may be. So because they're non-metals, their oxides are acidic. Now there is a quick trick I want you to understand here, that oxides of metals are basic, while oxides of non-metals are acidic, at least usually are acidic.